Welcome to the section of this course. Today I will be speaking about implicit functions of differentiation. Okay, how to differentiate the implicit functions. Okay, whatever we are differentiating till now, these are all explicit function. Explicit means we can convert it totally into x. Means, for example, if y equals to total function of x, okay, means total function of x, that's called what? Explicit function, completely in pure form of x. Okay, you can say pure form of x, completely means if y equals to x square plus e raised to x plus 10 verse x. Okay, these are y equals to this. Okay, this is function of completely x. Okay, therefore these type of functions are called explicit functions. Okay, whatever we have done, all differentiations are mostly these explicit functions. Here you can find directly dy by dx means differentiation this with respect to x. Okay, we have to differentiate with respect to x, considering those terms or those terms which are different from x, you have to consider as a constant. Okay, these are explicit function. Okay, now what is implicit function? Okay, now implicit function is function, for example, y is function of xy. Okay, it is mix of xy. For example, if I have x square plus x minus y, x is equals to y sine of x. Okay, now let's consider this. Okay, now here let's try to express y equals to some function. Okay, now for this we have to try to express y equals to f of x. Okay, you try to express this. If it is, you can complete the function of x, then that's explicit. Okay, if you are not able to, then that's the implicit. Okay, let's try to this. Okay, this, let's bring that side. Here we have minus yx, here minus y sine x. Okay, is equals to, here we have minus x square minus x. From here we can take common. Here if I take common, here minus x minus sine x is equals to x square minus x. Therefore y, if I send this here down, this whole will come over here. Still it is explicit form. Okay, let's take another example for implicit function. Okay, here if I have xy is equals to x cube plus y cube. Okay, if it is this, okay, if this, then find dy by dx. Now sometimes they may ask, okay, they may ask, be careful, they may ask dx by dy also. Okay, you have to be careful what they are asking. Okay, they are asking to find dy with dx. Okay, now here let's try to express whether y equals to completely function of x. Let's try. If it is possible, then that's fine, explicit. Otherwise that will be what? Explicit form. Okay, now if I bring y this side, is equals to xy minus y cube is equals to x cube. Okay, now here if I am taking y common, okay, still if I take y common also, it's mixing. Okay, it's mixing means if I take y common, x minus y square is equals to x cube. Therefore y equals to x cube upon x minus y square. Okay, these type of functions are called implicit function. Okay, here okay, we have mixed with, this is mixed with f of xy. Okay, now if y is mixed with f of xy, then that's called implicit function. Okay, now at the time of finding dy with dx, it may come in mix of x and y. Okay, don't worry. In explicit functions, your value will be only in terms of x. Okay, here in implicit function, it may be mixed. Okay, mixed with x and y. Now let's try to find this derivative. Now differentiating with respect to x. Here we are with respect to x. Why? Because here dy dx. Okay, here differentiation is they are asking dy by dx. Okay, here now we have, let's omit this. Okay, now here you have to apply the product rule u into v. Okay, here x keeping as it is, I am differentiating d by dx of what? Y. U v ds. Okay, plus y formula y, again d by dx of x u into v rule. Okay, on the left hand side is over. Here on the right hand side, d by dx of, here differentiating. What is your differentiation? Be careful here with respect to x. Okay, here d by dx of x cube with respect to x is what? 3x square plus, here y cube will be what? 3y square, again dy by this what? D upon dx of y. Here what we have is again d by dx of x, that is 1. That's therefore we have not written over here. Okay, here this is dy by dx will come. Now is implies x. Okay, here x into dy by dx. Here if I collect dy by dx, okay, here I can write dy by dx. If I am taking common here x minus, okay, this term will come, this is dy by dx minus 3y square. On the other side, we have this, and this is d by dx of x is what? Dx by dx is 1. Okay, here what we have is equals to 3x square minus y. Okay, therefore dy by dx is 3x square minus y upon x minus 3y square. Now look at here. Okay, your dy by dx is what? It's involved x and y. Okay, now look at the given equation here. It is of xy equals to x cube plus y cube. Okay, you see over here, if you substitute something, are you getting something so that it may be somehow smaller one? Okay, now these are the 3 implicit functions equations. All these 3 we have to find dy by dx. Okay, all these 3 we have to find dy by dx. This is quite easy one. Then in the next part, so we'll take some advanced functions. Okay, now solution 1. Here what we have to do is, now we cannot separate y equals to totally function of x. We cannot separate here. Okay, therefore we have to differentiate with respect to x on both sides. Okay, by differentiating this on both sides, this one. Okay, on both sides what we have is dy by dx of x is what? 1 plus dy by dx, because we are differentiating with respect to x, is equals to now here dy by dx of sin x is what? Cos x. Consider this is some theta. Okay, some parameter u or v. Okay? Therefore dy by dx of sin is what we have? Cos of xy into, now we have to differentiate this x into y with respect to x by applying u into v rule. Here x into dy by dx plus y dy by dx of x is what? 1. Now collecting those terms which are dy by dx on left hand side or right hand side, another side, and those who are except from dy by dx, let's keep other side. This implies dy by dx. Now if I am collecting, okay, now here I will have 1 minus dy by dx term is, if I multiply cos xy into this, I will get another term here, x into cos of xy. Okay, this term is equals to Here another function, we have cos xy into y. Okay, here I can write y into cos of xy, here minus 1. Okay, therefore sending this down, you will get dy by dx. This implies dy by dx equals to y into cos of xy. Cos xy is particular angle, minus 1 upon 1 minus x into cos of xy. This is the required answer for dy by dx. Okay, now here if you have sin xy, you can substitute x plus y, and here cos xy we have, so you can keep as it is. Okay, now solution of 2. Here this is pi. Okay, here pi is constant. We have sin cube y plus cos of xy is equals to pi. Now they are asking dy by dx. Be careful what they are asking, whether they are asking dx by dy or dy by dx. Okay, now here we have to differentiate with respect to x. Here be careful, here we have y. Okay, now sin cube y is same as sin y the whole cube. Okay, therefore differentiation is this 3 sin of y the whole square. Okay, so I can write sin square y into. Okay, now since I am differentiating with respect to x, we have y. Okay, therefore what will get d by dx of y, or you can say dy by dx. Okay, this is over. Plus differentiation of cos is what? We have minus sin x. Okay, here we'll have minus sin of xy. Again here we have to apply u into v rule. Here x into dy by dx plus y, and differentiate second function y into 1. Okay, y into 1 is equals to different dy by dx of constant is what? 0. Now collect those terms which have dy by dx. Here dy by dx common, I am taking common, and what we have is here 3 sin square y. Another we have over here. Okay, here is minus x sin of xy. Okay, is equals to those term which doesn't have dy by dx. Let's bring another side, right hand side. Here we have, okay, here minus, we have it become a plus y into sin of xy. Therefore dy by dx, sending whole term down, what we have is we have 3 sin square y minus x sin of xy upon y sin of xy. Now here, as I told you, this dy by dx is function of xy. Okay, here you are not getting only function of x. So here in implicit functions dy by dx you will get, this is what? Function of x and y. Okay, therefore it is implicit function. Okay, if it is only x, that's explicit function. Okay, now our topic is implicit, therefore you will get mix of x and y. Look at here, do you have anything which you can substitute over here? Do you have any sine cube? Here you don't have any sine cube, cos xy, so that you can stop over here. Okay, now next sum is solution of 3. If okay, x cube into y equals to log of x square plus y, this is log, okay, plus sine of e raised to x, and find dy by dx. Here you have to differentiate with respect to x by applying u into v rule over here, by differentiating on both sides. Okay, here left hand side, here we have right hand side, and left hand side we have mix of x and y, here we have a mixture of x and y, so we cannot separate y equals to only function of x. Therefore, since it is implicit, we have to differentiate with respect to x. Okay, here u into v rule, different x cube into here you can differentiate this. Okay, I am differentiating x cube will be 3x square. Okay, and I am keeping y as it is, plus I am keeping x cube, again differentiating dy by dx. differentiation got over here by applying u into v rule. Here, since log is this, okay, since log is this 1 upon x square plus y, again we have to differentiate this with respect to x. X square plus y with respect to x is what? dy dx of x square is twice x plus, here we will have dy by dx plus dy dx of e raised to, here differentiation of sign is what? We have cos of e raised to minus x. Again, we have to differentiate e raised to minus x with respect to x is e raised to minus x. Again, minus x differentiation will get minus 1. Here we have minus 1. Okay. Now collect those terms which having dy by dx. Here I am taking dy by dx common. Here we have one term. We have x cube. Here we have one term, so you have to multiply over here. Okay. Here is we have minus 1 upon x square plus y, okay, is equals to this into this, we have twice x upon x square plus y, and this term we have minus e raised to minus x cos of e raised to minus x. We have this term minus 3 x square y. What I am doing is I am collecting those terms which involve dy by dx, and those terms which are free from dy by dx I am keeping on right inside. Okay. Now dy by dx equals to is implies dy by dx is sending whole this term down. Okay. You will get this, right, whole this term. Let's call this is A and this is B. Therefore dy by dx is what? A upon B is the required answer for dy by dx, that is function of xy. Okay. Thank you.